session. Okay, so I would like to thank you, Dr. Ahmed, for your time. I know you are a very busy, actually, reservoir engineer in Petronas, so that's why and giving us this time really it's honor for us to have you among us. So without further actually due, I give you the actually podium to start the session. Of course, first of all, we would like to know about your career and brief overview of what you have done. Thank you again for your time and joining us as an industry talk. Thank you very much.
It is my pleasure. Thank you for having me, Dr. Mansoor, and a student from UTM. I mean, it is my pleasure to be here and hope I can share with you some thought about the industrial, and I try to share some experience with you guys. And I need, because this is a WebEx, I need to share my screen. Just let me know I switch off my video first.
Okay,
And
great.
I need to share my presentation. Share. Hopefully you can see my presentation now.
Yes.
You can see it in full mode, right?
Yeah, yeah. Others, how about others, students? Can you see the presentation?
Yes, Doctor.
Yes.
We can see the presentation.
Oh,
Okay,
great, great.
okay. I will start without any delay. So, assalamu alaikum, and still morning, I believe. Yeah, very good morning to all of you guys. I am presenting from Kuala Lumpur, and today is a weekend also. You guys, I think you are in the class and you are doing as usual. So the title that I chosen for today, and I'm gonna to share with you guys, mostly regarding the fundamental of the field development plan, and but I make it in two phases. One, just briefing you high level what we are doing in the field development, and after I try to catch about the formation evaluation that normally you need to I try to go very basic and very, I mean, high level, and let me know if you have question or you want more explanation as well. So in the beginning, I try to brief myself. So my name is Ahmad Khanifar. Actually, I am staff reservoir engineering in Petronas since 2010, almost 14 years I am with Petronas, and 22 plus years of the working experience actually. And most of my I am purely reservoir engineering is mean from day one, from the study in my PhD, and after that working level. My chance was involving in many projects, including for example, the field review, FFR, FTP, in-field drilling, IOR, EOR, and now I am working mostly on the CCUS project for Petronas. And there is a many paper that I able to publish regarding those kind of the finding. And in the same time, I am the committee member of some of the conference and also external examiner of some of the university. And today it is my pleasure also to be here, and thank you, Dr. Mansoor, for inviting me for delivering the talk to the UTM student. So, I mean, in the beginning, just I try to give you, I mean, what is the motivation for you guys to study petroleum engineering in general, and why we need to talk about the oil gas industry. What is the motivation? As you know, the objective normally finding the hydrocarbon resources, right? So we need to find the resources, and we need to produce those resources, and we need to sell it, and we make a cash, make a money, right? So normally the objective for I mean the oil and gas industry, we need to answer how much oil and gas is present. So as a analysis that reservoir engineering, petroleum engineering, all the discipline engineering need to be done. They need to know how much oil and gas is available subsurface here. And after that, out of that amount of I mean the oil and gas present, how much can be recovered? and how fast we can recover, because the fast is mean more money. Is dependent to the oil and gas cost, and how much cost also will involve in this project in terms of the OPEX, in terms of the CAPEX, and in terms of the reservoir management and strategy, which kind of the management reservoir still we need to take in the action, and for example, which kind of the surface facility. The graph below in the left, the big one, you can see this is the oil reservoir, that normal anticline oil reservoirs. And after that, in the other graph, the small one in the right side on the top, you can see the different type of the trapping for the oil that I believe you will go through the study. And this is just beginning of my presentation. Anything? It was here background. Okay.
I don't think it's real. I think that was a
Okay,
technical issue.
sure. Sorry. So I mean, so I start with this one. So this is a field producing life. So you might seen this graph before. There are two main graphs in the bottom, one in the left side. We call it oil field primary. This is the plateau, this is the production profile. And this is a for the gas field, as you can see here. So you might seen this graph, both graph before. This is the typical producing life of the field. So we start with a production, for example, here from the field, and there will be some phase development of the field, build up. We call it build up period here. What that means is the well will not drill in the same time. Normally it is a sequence, right? So they are drilled in the phases, and then the production will increase with the time and reach to some level of the plateau. We call it plateau. The plateau is some kind of the maximum rate that we are planning to offtake from the reservoir, and this is dependent on the offtake rate, which we'll consider, and then it is entered to some decline curve after that. So this is understanding the plateau and offtake rate of the field is very important. And this is a typical producing life of the one oil field. The important question normally is what is the offtake rate should be, and this is based on the size of the reservoir. And normally, if the field is very, very huge, very big, normally we consider 2 to 3% of the initial oil in place. Well, normally we consider as an offtake rate of the reservoir. But if the reservoir is small, so normally we go with a higher rate. The offtake rate is mean how much per year I need to produce, you know. So say, for example, you have a 1,000, just say we have 1,000 barrel of the oil down in place. So I need to produce 2 barrel per year, for example, something like this. And this is where this will tell you how we need to plan for the many well, and where we should drill the well, and how the well need to be completed. So the offtake normally will guide us in terms of the number of the well need to be drilled, number of the well need to be completed, where should be drilled, and other questions that normally can be answered. The second graph in the right side, you can see it is related to the gas. Okay. There are the two plateau. It means two constant rate. One is a blue, one is a red, right? So this is a different situation here. Normally for the gas, we need to maintain we need to maintain the plateau for a specific period of the time. And this is because the gas we need to supply to the customer. Yeah, when we produce, we need to sell it, or we need to give it the customer. And this is where we have a commitment with a supply and a demand. And normally this is where we need to decide where we should send the gas. And based on that one, we will decide on the plateau and the profile of the gas. And normally, if, for example, in the red case, in the red color one, as you can see, the plateau is smaller, but we can produce for longer time of the so this is very important from the FTP point of view. We need to understand the oil field, the gas field, how we can produce, how we can develop, where is the customer, you know. This is all telling us how we can develop the field, right? in the top left corner also you can see graph of the IOR. EOR is mean we by natural depletion, by normal depletion, you can develop such a production profile, but sometimes you need to go for the other stage of the field development. We call it IOR, improve oil recovery, or EOR is mean enhance oil recovery. That this is just giving some kind of the comment or feedback later on for your understanding, and normally the field can goes to the other stages as well. And by doing the IOR and EOR, we can produce more and more from the field. I think for this graph should be enough. So let me go for the second graph. So here just I am briefing you about the type of the fluid. As a student or as a petroleum engineering, reservoir engineering, whatever, you need to understand there are many types of the fluid. This is another aspect, important aspect of the field and production in the type of the fluid. In this slide, you can see the variety of the crude oil in the bottles. Yeah. In the left, which is a lighter color, is the lightest oil. And in the right side, this is the heaviest oil, that normally dark color one. Yeah. Heavy oil and lighter oil in the left. So normally they have a different property, they have a different viscosity, they have a different density. And this parameter need to be taken in consideration when we formulate a one field development plan, and normally and during the production also. So the point here is very light sometimes will produce more gas or more high GOR, but the heavier very difficult to lift, yeah, in the well. So we need to produce the heavier. Normally we cannot be easy like the light oil. So we need to see which type of the oil we are dealing with, and based on that one, which kind of the field development need to be considered, right? And similarly for the gas field, as you can see in the graph also in the below left corner one, you can see the type of the gases also. For the gas also, we have a several type of the gas reservoir. Normally we have a dry gas, wet gas, and condensate gas. That following slide, I will show something about that one. The important message would be to convey here is that all the reservoir with different energy mechanism, with a different fluid type and different rock property should manage differently. Yeah. So we need to understand which kind of the reservoir we're dealing with, and based on that one, case by case will be different. And on top of this, during the production phase, they introduce another aspect of the changing phase behavior that is also very important. So this graph will show you some cartoon about the changing of the phase behavior. For example, in the bottom left corner, you can see oil reservoir, and undersaturated is mean this is a liquid, and when it is produced along the wellbore and bring to the surface, to the separator, to the stock of the tank, you can see some of the gas will release. So you can see the phase behavior of this sample will change. So understanding how this phase behavior will change, very important, and normally you will understand during PVT modeling that and PVT study that I believe in your course also you will understand about that one. And in the bottom left corner also you can see two situations. One is the oil reservoir that is producing in the surface. We will have oil and gas, and we will have one gas reservoir in the most right corner, that when we produce this gas, some of the condensate can produce. Condensate is mean some drop of the liquid. So understanding which situation we are, we need, for example, we need to take PVT sampling. We need to take some sample of the reservoir and we need to analyze. We need to do it in the lab. And after that, we need to interpret those results. So normally we can have a PVT sampling in the bottom sample, or we can have a surface sample. Is dependent on the situation. We will decide. And also there are many kinds of the PVT analysis that based on each situation normally we conducted in the lab. here also I want to brief you about the system energy. Is
Ahmed,
mean yes.
is it possible to ask a question about the previous slide?
Yeah. If you
Yeah.
want to go Q&A here, it's possible. In the end of the situation also can, but interactively is better anywhere. I mean, up to you, Dr. Mansour. Yeah.
Yeah. I think the students already know about the laboratory analysis,
Very nice.
conventional, and also SCAL and PVT. So and more generally, it's about formation evaluation. So that's why just a brief speech about how this data will be acquired from the field, and how this data can help petroleum engineer in the development phase. This is just a general about and then that's a very great cartoon here showing actually different phases in terms of saturated or undersaturated or other things. But the thing is, this is more about how to evaluate this, whether this in drilling phase or in production phase or any other phases that you might have some guidance for the students.
Okay. You want to see the formation evaluation, you mean?
Yeah.
Okay, I mean, because this is the reason I put it here. This is like the storyline to reach to that point, but I can skip some of the slide, or I can go faster if the student they don't want to see this one.
No, this is very, very good, very informative.
Yeah. So I try to get your point. Shall I proceed, or you want
Yeah,
me?
please. Thank you.
Okay, sure. I mean, maybe, I mean, this is the reason that I put here, just I will reach to that formation and how we can get that kind of the data, and how we can analyze which kind of the tools we are using, how we do the formation evaluation. Just in first part of my presentation, I try to go from high level to that point to give
Great.
a solid storyline. So, and after that, I will go in some more detail about the formation evaluation. So in this slide, mostly I know, as you mentioned, students know about this. This is just recap. We talking about the system energy. So is it from the FTP point of view, it is important. There are a various of the reservoir, and each reservoir cannot develop with the same strategy. This is the message. When we have a dealing with a different energy system, you need a different strategy for development. So this is a very simple schematic that you can see where the reservoir, you can see the gas in the top, you can see the oil and water, and may have various combination of the gas, also no oil, no water. It may have oil without water. There are various of the type of the reservoir, and popularity, they are categorized based on the energy system, as you can see. Normally they name is a depletion drive, gas cap drive, water drive, combustion drive, gravity drainage, and combination drive. So it's dependent on the situation. So the message here, as a FTP, as a person who working on the field, you need to understand which kind of the situation you are, and this is based on the formation evaluation and the data that we are collecting, and I will show you in the following slide. So this is the link between my slide and what the student want to see in terms of the formation evaluation. So based on that evaluation, you need to understand which kind of the system you are dealing with, and based on that one, you need to go for the development. And this slide just summarizing the in each situation. For example, when we say depletion drive, what that mean, gas cap drive, what that mean, and combination or water drive. So I believe all the students already aware about this one, and I just move smoothly. Okay, one of the important point that field development is important in terms of the development of the field, understanding the life cycle, you know, about the field. So what did that mean? In summary, the field life cycle of any oil and gas field start with a discovery. What that mean? Where is the field location is discovering, you know? by conducting and interpreting the seismic and then drilling exploration well, the discovery will be completed. So first we start with a discovery, where is the oil reservoir? And upon the result of this stage and confirming the subsurface potential, the second stage will plan by drilling the appraisal well. And this is where we focus on the evaluation, and this is one of the points in terms of the formation evaluation. And here where we can evaluate the reservoir in terms of the reservoir structure, reservoir connectivity, for example, reservoir hydrocarbon, and so on, you know. So this is a key stage of the field development, because we need to make a decision, you know. After we appraisal the reservoir, we need to understand, we need to evaluate if this is a worth to develop the reservoir or not. This is where we call it as a making decision. It is about to proceed or do not proceed with a field development plan. Normally it takes 1 year to 3 years to complete this stage. And based on the result, we will decide on the important aspect of the reservoir, including the geologic structure, number of the fluid unit, rock property, fluid property, driving mechanism, and all the formation evaluation can be conducted in this stage. And it is important of the how we conduct those kind of the formation evaluation. And this is where it is the formation evaluation is very important, because all those input will go in the making decision, and this making decision is mean money, you know. So you need to be sure the money and the investment that we conducted, it is worth, and we can return those money, you know, after some time. So after we make that one, we need to go for the other phase of the drilling, completion, and make them development stage. That normally is take one of the, after we make a decision and we said there is a good to go, we have a good amount of the oil, we can have a good amount of the profit from this development. So normally we go to the development where we drill several wells, we complete the well, we start the developing the phases, and normally this will take 1 to 5 years. And after that, we go to the when we reach to the offtake reservoir target and everything we develop. So normally we go to the full field production of the field, and normally it takes 10 to 15 years, you know. At this stage, normally the reservoir management plan and data acquisition plan are the key point for the better asset management. And after that, normally after some time, the reservoir will go to the abandonment. This is where we need to shut off the field, and we call it decommissioning period, you know. So understanding those period and where is the making decision is very important. So this is the relation between the field life cycle and the formation evaluation. So because that the formation evaluation is very important. Why? Because the input from the formation evaluation give you the tools, or you give you the ability to make that decision for the input, you know. So making decision, what that mean to decide to do or not to do, you know. And how we can do this one, normally we need to do the economy analysis. In the graph below, maybe you seen this one earlier. This is the cash flow versus the phases of the life cycle. In the beginning, when we exploration happening, normally we do the investment, we don't get any oil yet. And after that, the appraisal, also normally we don't have a much oil yet. We just investing, and we giving money, because that the cash flow is minus, below zero, right? And after that, when we stage in the development and production, normally where this is where we can produce the first oil, first gas, and we can sell the oil and gas, whatever. And this is where we can make a money, and the money that we invest can be returned. And this is the cash flow, and normally you need to understand in this situation. So so it is important, the technical capability and the awareness of the field development team is very important to make that decision. And this is rely on the input that we get from the formation evaluation. If you have a poor formation evaluation, definitely you will end with a wrong result, wrong interpretation, you're making a wrong decision, and after you're losing the money. So the link that I want, the important message here, the formation evaluation, very important for the making decision. And as I mentioned here, just the appraisal is the key stage. When we do the appraisal, what that mean we're drilling the appraisal well, and based on that one, we do some kind of the logging. We do some the coring. We can that is in following slide. I will show you about the formation evaluation, and based on this result, normally we reduce the uncertainty in terms of the hydrocarbon in place. Can be gas, can be oil. Description of the reservoir is mean what is the porosity, what is the permeability, what is the deliverable of the reservoir, and all this kind of the parameter that is part of the formation evaluation. Normally, this can be decided in this stage and can be obtained, And in terms of the field development, so just the field development plan, normally we call it FDP. This is the very important document normally. And this is a process to evaluate the multi-scenarios that can be considered for the field. And we're selecting the best option to develop the field based on the formation evaluation and economy analysis that we conducted. And normally the driver for this one can be net present value, the key driver of the decision, how much money I will gain, oil and gas recovery mechanism, operation facility and scalability, and capex versus operating cost, OPEX, technical operating. So all these kind of the parameter based on the formation evaluation. So this is just all this slide that I am showing just to show you how important the formation evaluation and how related to the field development plan. So in the end, the cost need to be minimized, the quality need to maximize, and the time need to be optimized. So all these triangle of the field development is related to the formation evaluation. And managing of the FTP is dependent on those kind of the formation evaluation, and is dependent on how you understand about the reservoir, which type of the fluid, oil or gas, offshore or onshore reservoir, structure, how look like, formation, everything, energy system. So all this formation evaluation input need to be consolidated, and this is where we can manage FTP case by case, And for the FTP team, normally several team will work together. We have a geology, we have a reservoir engineering, we have a drilling, we have a subsurface team, surface team, business team, management, all working hand to hand together. They putting all the data together and making the FTP team. Okay, and now I am starting to go to the formation evaluation, I mean in more detail. This is the activity that we need to first to the oil, first oil. As you can see, number one, you need to do the FTP study here where you collect all the information, especially the formation evaluation result, making the simulation run and generating the several scenario for the development, running the cost, economy, and you can see this is the best option, understand the uncertainty. And after that, you will decide on the design of the subsurface and surface facility. After you can purchase the material you need to fabricate the facility. In number 5, you need to install the facility, commissioning and testing. And after that, this is where you can produce the oil and gas, and this is where you can start to developing and producing phase, and this is where you can make a money. So as you can see, to reach to this stage, the main driver is how I have understanding about the formation. So this is why the formation evaluation is very important. So in terms of that one, you need to establish one of the dynamic modeling, and the dynamic modeling need the input from the formation evaluation, and this is as a reservoir engineering or as a FTP team, our responsibility to build the dynamic model, and we put all the formation evaluation result in the dynamic model, and this is where we can have the result in terms of the FTP. So in order to go for the reservoir simulation model, normally you need first to build the static dynamic modeling, the static simulation model. This is where normally the geophysics, geology, and petrophysics hand-to-hand working on the static model. The formation evaluation here, for example, for petrophysics, they need to run they need to analyze the log where we have the formation evaluation. I will talk about the log here, where we can understand about the porosity, permeability, phases, fluid saturation near the wellbore. And in the geophysics, this is where we have an evaluation of the formation regarding the seismic. Where is the sand? Where is the shale? How extend the sand? What is the thickness of the sand? And how kind of the fault or formation, boundary, all this is from the formation evaluation in the seismic, you know, the geophysics responsible to answer all the questions. And geology, this is where they talking about they will extend the log within the wellbore to the area far from the wellbore, and when they building the static model. After they building the static model, they give the static model to the reservoir engineering. This is where I mean in the my first part of this presentation will finish. Just give you what is the FDP, how we do the FTP in general, and what is the key driver of the FTP is the formation evaluation. In the end of the day, we build one dynamic modeling, and this dynamic modeling input, this is the element of the formation evaluation. We have a reservoir description. This is come from the static modeling, the log data, the core data, the well log data, well test data, fluid property data, and if any historical or drilling report data, everything, and the facility and historical data. All this data will go in the simulation model, you know. And so this is the formation evaluation, very important. I will stop here for the while to see if there is a question. After that, I will go directly to the formation evaluation, how we do the formation evaluation, and what is the other in more detail. And I try to cover what Dr. Mansoor would like to see mostly. Yeah, here. Any questions so far, please? Okay, I think there is a no question, and that is mean it is the slide is very clear. So now I will go to the second part of my presentation that mostly talking about the formation evaluation. Okay, what the formation evaluation mean? Okay, the formation evaluation is a process of interpreting a combination of the measurement taking inside the wellbore. What that means we drill a well, and now I need to understand, and I reach to the reservoir, the target reservoir, and I need to understand and to see what will in the reservoir, what is we need to detect and quantify the oil and gas reserve in the rock that is near to the wellbore. Okay, we need to study the physical property of the rock and fluid within that area. You need that we reach through the drilling. So and normally this kind of the formation evaluation will do with a wire-long logging instrument or logging while drilling tools. So it means we drill the well, after that we send the wire logging, or no, we drill and in the same time we do the logging from the same tool. And normally we gather all the data and we interpret it versus the depth of the measure depth that we call it as a log, and those log of the data will be interpreted in the different matter, is dependent on which parameter we are measuring, that I will show you in the following slide. So in the general formation evaluation, talking about the collecting the data, physical data of the reservoir and rock in the wellbore area, right? So why I need to do the formation evaluation? As I show you in the first part, the most important of the formation evaluation, you provide the input for the target reservoir, for the formation reservoir to the simulation model, you know. And those kind of the formation evaluation based on the graph that you can show, this can be log data, can be PVT data, can be drill steam test that I will talk one by one about the core analysis, can be testing the fluid, testing the rock, and other aspect of the reservoir can be analyzed based on that formation evaluation, you know. We can analyze the formation pressure data also. We can analyze how look like the injectivity and productivity of the formation through the evaluation. But the important things, all this result of this formation evaluation will be input for our modeling and our formation, our FDP model that later on make a big decision. One of the tools and one of the formation evaluation that normally we call it mod logging. What that mean, when we drill the well, some of the drilling mod will come in the surface and drilling bit cutting, right? So those kind of the very good indication for us to analyze. And normally this kind of the reported during the report of the drilling well, it is important to be analyzed, and those data provide some kind of the calibration and verification in terms of the type of the fluid that we are dealing with, if we can see the oil, gas, and other aspect of the cutting. So those cutting of the reservoir can give us in terms of the information about the reservoir. So the mod logging, because that is very important, and normally the petrophysics also will use those data in terms of the calibration and verification with other data when we have a logging. Yeah. Other aspect is a coring. What the coring mean? Coring is mean we go in the well and we take some sample of the rock from the subsurface, from the formation, right? So this is we call it coring, and normally by taking the sample of the reservoir, a small it will be representative of that reservoir, and we take this core to the lab and we measure most of the property of the rock of the fluid of the rock of the reservoir, and this is we can determine the lithology that describe the reservoir. We can determine the porosity. We can determine the permeability, fluid saturation, grain density, and some of the other aspect of the fluid flow parameter that need to be taken in the lab. So all this kind of the parameter, by doing the coring, is mean bringing sample of the reservoir from the subsurface to the surface. So in terms of the doing the coring, normally there are two methods commonly used for the coring. One, we call it the hole coring. Is mean when we drill the well, we put the coring bit, and this is where we can collect the big amount of the core as a cylinder of the rock that normally in diameter can be between 3 to 4 inch in diameter, and in terms of the length can be vary between 50 to 60 feet or 15 meter, 18 meter, long. So normally if the reservoir is not really battle and can be solid, we can go for the hole. You can see the whole core in the sequence, one solid rock. But if the brattle and will be cannot be very unconsolidated one, you cannot see whole, and it's you can see broken when we collect the data, so this is one of the way of the coring, and this is we call it the whole coring sampling, and very important after that. The other type of the coring, and the whole coring normally is happen when we drill the well, but the other type of the coring, we call it side well coring. In this situation, normally after we drill the well, maybe we miss the drilling, or we don't plan for the whole coring. Normally we will receive some kind of the request that I need to make the understanding about the core data, go and collect some core data. In this situation, normally the side well coring is advisable, and normally the tools will send to, and as you can see in the carton, you can see we will have some kind of the gun, and the gun will stick in the area that we need to take a sample, and the gun will shot, and in that case we can have some coring, a small size of the sample, and the sample will collect it on that barrel, and we can bring it in the surface, and we can do the analysis. The advantage of this kind of the side side well coring normally is a low cost, and normally the sample we can collect it is much easier than the whole coring, and also the reservation, and after that the keeping the sample also much easier, you know. And during the coring, one of the important aspects of the coring, preservation of the coring, is mean you need to preserve the core from the touching to the surface, and it should be remain unchanged as much as possible, because when you bring the core in the surface, definitely it will be exposed to the ambient condition, the pressure will release, will touch the air. So the core should be prevented from the drying out. Is mean it shouldn't be dry, coming in the contact with the oxygen and being mechanically damaged, you know. So we need to avoid this situation. So because that there are several type of the preservation of the core, is dependent on the type of core. In the in the graph below, in the slide ABC, you can see how the team, they putting the core inside of the container, and after that they sealing with some material like the wax and other parameter, and they try to prevent the original core when they take it off in the surface to touching with ambient with contacting with the surface situation, and they try to keep it as much as possible preserved to until sent to the lab, and after that we can start the measurement. So the measurement. So sometimes the in situ measurement also very important. So after we have the core in our hand, normally we need to do the analysis for the core. So in the petroleum engineering, in the reservoir engineering, when we're talking about the core analysis, normally there are several type of the category. Normally we're talking about the core, but two of important one, we call it routine core analysis or conventional core analysis, and the other one we call it special core analysis. There are different between two, and normally the routine core analysis very simple and straightforward, but the special core analysis normally is customized based on what we need and what we are looking for, right? So for the routine core analysis, normally we need to understand about the lithology, we need to understand about the residual fluid saturation, we need to understand about the porosity, ambient permeability, and the grain density. So in this situation, normally, as you can see in the graph, you can see piece of the whole core under the coring bit, and normally we take off one plug. The plug can be normally 1 inch and 1.5 inch in diameter and 2 inch in the length, and the small piece of the core. And normally that core will take to the some equipment that I believe in your university you should have it. So easily we can measure the porosity and permeability and grain density. I believe in most of the university you can measure. So this is a kind of the example of the porosity meter that normally we measure the porosity of the core. We as you can see, there are a core holder, and there is we put that plug there, and there is a guideline and procedure, normally helium base on other base. We can measure the porosity based on some physical property, and I believe you will learn about it during conducting the lab in the porosity measurement. In the other slide, you can see the permeability measurement. is dependent. You want to use the gas permeability measurement, or you can use a liquid permeability measurement. There are a different in terms of the way, because for gas there is a slippage phenomena. Normally the gas is much easier because it will not the gas easy to not really make an impact on the surface of the rock, but there is, due to the slippage effect, normally you need to repeat several times, and you need to consider some kind of the Klimberger effect later on. I believe you will study about that one. And normally in the end of the day, these two permeability that we are either we measure from the gas method or we measure from liquid method, they are equal and should be equal, because the permeability is meant the conductivity of the rock to the fluid flow, right? So it is the same for each reservoir, for each sample. So this is a tool that I believe you either you already done or you will do in the future, and you measure the permeability of the core. In terms of the special core analysis, normally, as I mentioned, this is a base on customized one, but most of them, first you need to understand the porosity and the permeability based on the routing core is in the ambient condition, is mean under normal pressure and in the room temperature, for example. But as you can see, our reservoir under 1,000 or meter below, right? So it is under compaction or under stress, right? So the porosity and permeability will be different when we bring the sample in the surface, because you're releasing the pressure, right? So one of the aim of the scale analysis, you will to see what is the deviation from porosity permeability when we go the stress or when we bring the surface in the real situation subsurface, right? So here we can measure the porosity and permeability under the confining stress. Different confining stress will give us different porosity, and after that we will adjust the porosity and permeability from routing data to this scale data. And the difference here, normally the scale data is very expensive, very time consuming. So because that routing is very easy, very simple, can be done within maybe 1 week, right? So because that routing is very several, and normally we take as much as we possible the plug sample, but a special core analysis, no, based on some plan, and normally we go less number of the core, because as I mentioned, very expensive, time consuming. So here, like we validate or we calibrate the routing data by scale data, you know. And the other parameter of the scale data, normally we measure the capillary pressure. That is very important for the initialization of the reservoir model. I believe you know what is the capillary pressure. Here we can measure the capillary pressure, and there are several methods to measure the capillary pressure. That is, one of them is a Prosper plate, or one of them is centrifuge, or one of them is mercury. So I am not sure in your university which one you have, or you does not, I am not sure, but there are several common method for the measure of the capillary pressure. And after that, we measuring the relative permeability and the wettability. The relative permeability, the behavior of the fluid flow. The other was static, is mean we don't inject anything, we don't produce. But in terms of the relative permeability, we need to understand what is the fluid flow behavior of the rock and the liquid together. So here where we call it the relative permeability, and I believe theoretically you understand what the relative permeability mean. Here we measure the relative to the gas, to the water, to the oil, and here we can prepare the input that's required for dynamic modeling, and we can measure that one. So this is the important part of the scale data. And after that, when this is regarding the core. Now we are moving to the log, and normally this is where the petrophysical very important. Normally one of the other formation evaluation, and very basic one, very important. When we drill a well, normally we do the logging, and normally this logging is provide very important parameter and about the formation, but this information need to calibrate it with the core data. So this is the link between the core data evaluation and logging data evaluation. It means we do both, but in the end of the day, the log data need to be calibrated with the core, because the core is a real direct measurement, but the log is an indirect measurement, you know. So what is the open hole logging mean? Actually, the open hole logging, or known as the well logging, is a practice of making the detailed record of the well log, the geologic formation penetrated by the borehole. Yeah. So normally we send the tools and we start from the down to active. So the graph here that you can see for the SP, or the resistivity. So this is some kind of the measurement of the parameter that normally based on which kind of the parameter we need to measure. Normally we put the tools in that one and we measure the parameter. So what is the principle of the well logging? So as you can see, the tools that in the graph, the guys he's sitting with the tools next to the tools of the well logging is dependent. There is a several element, but normally the well logging is a record of the certain formation versus the depth. And normally the measurement will start from the deep depth, and will move when we move up the tools, the reading will take in the action, you know. And normally we measure the electric, acoustic, and radioactive property of the formation, because each formation has some kind of the electric, like the SP, or radioactive property like the gamma ray, as a natural of each formation. Normally we can measure those, and in the other type also we can sense some kind of the parameter, and like the acoustic parameter, and we can put a device to collect the return from that as a receiver, and we interpret those data as a formation logging. That I believe in the course of the logging you will understand mostly in terms. So I want to just make it very simple for you guys. So we have also logging while drilling. That this is as mentioned. Logging while drilling is mean when I drill, in the same time I can make the logging as well. So this is there are many there is a benefit in this case, that we can have the in the same time I can track the logging. And especially in the infield drilling, I have a several case when I was working on the infield drilling project. For example, I already give a direction or location to the team to drill the well, you know, and they start drilling the well, and in the same time I can see the log interpretation in my screen in my KL tower, you know. So the field in the Sapa, in the offshore, in the very far from the tower people, but in the same time through the technology we can see the result of the well logging in my screen, in the lively, you know, live, very live. In that situation, for example, I put one target of the reservoir, and unfortunately, due to some uncertainty, we cannot reach to this reservoir that we are targeting. We cannot drill. It was some miscalculation, you know. So based on that result, I was comparing the plan versus actual. And after that, okay, I said, stop the drilling, move the well, for example, or deviate the well by some angle to other to get that target reservoir, you know. So this is one of the beauty of the logging while drilling, is mean lively I can have the some situation in terms of the my drilling plan. In the same time, I can collect many information of the reservoir, and I can guarantee that my drilling plan as per desire, you know. So this is a very, because in the end of the, this is a money. We're talking about the money. So logging while drilling is mean understanding the formation exactly lively when we are drilling, and those information can translate it in the formation evaluation the later on for the simulation as well. And normally when we do the live logging while drilling, normally we can collect several parameters like the gamma ray. It is a radioactive nature of the reservoir. We can measure the resistivity. This is we can measure the density and neutron. We can the sonic, formation pressure, formation fluid sample, and the caliper, and other aspect of the well logging. So this is just, I show you very simple analysis of the well logging analysis. I may you seen this one before, but this is one of the, in my most of the final year project that I am dealing with a student. Normally, this is one of the things that I am asking the student. So how you interpret the log data? So the answer will be normally this graph, simple graph. Normally, as you can see from moving from the left to the right, from the gamma rate, normally you will understand the formation that I drill, where is the shale, where is the sand based on the gamma. And after that, you moving to the middle one. When I know where is the sand, I need to understand if the sand containing hydrocarbon or not, or water. So this is where we use the resistivity log to interpret within the sand area. As you can see, where is the hydrocarbon, where is the water. And after that, when we're moving to the right corner, the neutron in terms of the bulk density, here when from the log data you can distinguish in the hydrocarbon zone which one is a oil or which one is a gas. Do we have a oil? Do we have a gas? And in the brine, if this really brine or not. So where is the contact and other aspects? So this is one of the fundamental of the well logging, how we do the logging and what is the expected interpretation from the well logging, you know. So this is, as I mentioned, the survey of the well logging is normally done from the bottom up. So we start from the bottom and normally we pull up in the surface and we record it. So we talk about the coring is mean taking the sample. We talk about the formation evaluation is mean we measure indirectly the property of the formation. The other sample that normally related to the formation evaluation is a formation testing. Is mean we can test the formation in such a way. For example, we can have obtaining the information about the liquid and the pressure, you know. So which kind of the sample we are dealing with, what is the pressure we have in the reservoir, mostly regarding the hydrocarbon that we have. Formation evaluation, that earlier I mentioned the logging mostly about the static parameter like the porosity, permeability, lithology, you know. But here mostly about the dynamic behavior, what is the pressure, if it is a oil, what is the pressure of that oil, and how look like in terms of the skin, what is the permeability, what is the deliverable of those well. So all this is calling the formation testing. And normally the formation testing can be done wireline testing, can be done DST or drill steam test, or we can done it as a well test analysis. So what is those parameter? I can talk one by one. So in the well test analysis, normally we have a two parameter that you need to understand, I believe. So you need to understand mostly we have a pressure buildup and drawdown test. Pressure buildup is mean we let the well is produced, and after that we close the well, as you can see in the top graph. And after that we measure the pressure versus time, you know, because when we close the well, the pressure will increase. So this we call it the pressure buildup, and those data will be collected as a pressure buildup test and normally can be interpreted during the well test analysis, you know. And normally based on those data, we can measure the KH, permeability multiplied by thickness, as a potential of the deliverable of the well, the permeability itself, the skin factor, the well productivity, and other parameter in terms of if the reservoir is bonded or not, volumetric, the size, if there is a fault or nothing, and many other parameter, you know. And in the same time, we can have a drawdown test as well. Drawdown test is mean the well is shutting first, and after that we let the well is producing with a constant rate, and we measure the pressure, you know. And again, the same analog we'll use to analyze those well test data, and the same data can be interpreted, you know. So this is the fundamental of the well test analysis. But what we are doing the wireline testing, mostly we need to understand about the reservoir pressure, you know. So we normally there are several type of the wireline testing, and the most important and famous one is a RFT. RFT is mean repeat formation tester, you know. Normally we send the tools, and after that in each different interval based on our plan, the tool will stop and we measure the pressure in that sequence. So, and that pressure in the end of the day, you will have the pressure versus depth, and each pressure will tell you which kind of the fluid also you can have. You can have an understanding of it, where is the contact of the oil and gas, where is the contact of the oil and water, what is the initial pressure, and other stuff, you know. So other example also, you have a formation interval testing or FIT. Normally this is very specific, and normally if you want to specifically in a special formation target interval, you need to test the reservoir. Normally much simpler, but most we are prefer to the go RFT, because the RFT is mean you can test all the formation from bottom to the up, and this is where RFT is an important parameter when we do the reservoir simulation and provide the understanding about the initial pressure, the contact, and other, where is the gas, where is the oil, and this merge with other log interpretation as well. And the drill stem, I think I have one or more two slide, and I will end my presentation. The drill stem test also, this is where during the drilling, normally we test the formation, and through normally we isolate that interval, and we measure the behavior of the flowing perforation by doing the build up and drawdown, several build up and several tests, as you can see in the graph. So normally we open we isolate from bottom and top the formation, the interval target formation, and after that we let the formation to draw down, is mean produce, and after that we shut that formation and we measure one cycle of the drawdown and build up, and after that we repeat again. Again we open and close, and in the end we pull up the tools, as you can see in the graph in the middle, IF by 1 and 2 and the other. So this is all the build up and drawdown cycle of the DST. And through the DST also we can understand the DST will tell us what is the productivity of the well, and similar to the basic that we mentioned about the well testing, you know. And the case hole logging, sometime because you know in the well bore, when we drill the well, normally we make it case, right? So because we want to isolate the well bore from the formation. But in some situation we have an open hole, is mean we don't have a casing in the below in the formation. Most of the time we put a casing, and after that we perforate the casing. So some of the tools they are suitable when they are open hole, you know. But when have a case hole, what the situation? So we have a specific tools that when we case the well bore, so we can measure also some kind of the parameter. So one of the parameter is a production logging, one is a reservoir monitoring logging, and normally this is where we can measure the parameter. One of the thing also, like the cement pod logging, that we need to understand how the cement behind the casing can be. So the case hole logging normally give us some flexibility to understand the situation if the case hole well bore. In the end of this presentation, I just would like to show you the YouTube for the drill stem test. And by end of this one, I will open for any Q session, and I think I done with my presentation. Let me see, the time is 12:28, so almost on time. So if it is okay, I just play this one, and hopefully you can hear the you can hear, right?
No, there is no voice actually. this case, this is a slipper, and then this is our actually the preparation of the tool. That's why you can see this will be sent down down. Oh, okay, Dr. Ahmed, I think he can continue with the, because we cannot hear any voice actually.
Really? Oh, okay. I
Yeah.
didn't know. So let me just I play back again if there is any setup here for the voice. I don't know. I am not sure what's happening here, but if there is any setup here for the
I don't think so, but I think we can continue with this if there is any actually any kind of description that will be seen from the
can
YouTube channel itself.
yeah. Let me
I
see.
don't think there is a special setup that needs to be uh, actually changed here in the PowerPoint.
I am not sure, but let me I play again if you can. Still you cannot hear, right?
No, but it's not played, Dr. Ahmed.
Oh, I see. Because I think it should be in the presentation mode. It is in the presentation mode. Maybe there is some kind of the
I think
error.
in these cases, you need to refer to the YouTube channel originally, and then
Okay, let me
play
do
that.
that one. Let me
Play
do that one. Maybe. I am not sure why it's not showing. Dr. Mansoor, do you have that one? I can share you to you and you present from there, or
Yeah. Please, no problem.
no? How I can send it to you now?
You can send it to my WhatsApp, and then I will share it. Oh, check from.
Yeah, I already sent it through my email, the link.
Oh, email.
Yeah, email to your email on the UTM. Yeah.
UTM. Let me check. Haven't received it yet, but
Really?
check the formation evaluation.
No, I think no.
Oh, okay. Let me the
No, I think this is the wrong one, Dr. Mansour.
yeah.
Sorry about that. I don't know why it is like this, but I send one more. Yeah, please. Yeah.
Mm. Oh, okay. Received it. Mm. Mhm.
You can have it, or
No. I received one email, but it's empty.
really? Maybe because the restriction of Petronas not sending the link. Can you open the file that earlier you sent?
Yeah.
The
I'm going.
last slide, I believe also it will be the similar link should be there in the PowerPoint, I believe, formation one.
I think I have some problem also with this that it cannot. But we can still go with a file with a YouTube
Okay, sure,
actually or your
sure.
presentation, and we can just see the video because
Okay,
there are
sure.
some captions on the video.
Yeah, sure. So
So that's why let's continue with your presentation, please.
yeah, I will make it again. You can see the slide.
Yes.
Yeah,
I think
sorry.
you can go toward the presentation mode, maybe, Dr. Ahmed.
Yeah, it is in presentation mode.
No, because we can see it in a normal mode, you know.
Yeah, sorry. Now you can see.
Not yet.
Really? It is playing here. Okay. Let me I stop sharing.
Yeah, stop sharing and then
Yeah,
again.
I think
Okay.
stop sharing, share. If there is a automatic, maybe the camera or okay. I don't think so. There is sharing. Okay.
Yeah, we can see now.
Yeah, maybe hopefully now it can work. Yeah.
So this is an anchor actually. This needs to be picked up before running because this will go through this kind of string and this will be connected to the drill string, and then this is tightening is going on. And this anchor needs to be connected, to the string. Okay, as you can see, because there is no voice, Dr. Ahmed, I need to
Yeah, please. Yeah. Yeah, thank you very much. Yeah.
Okay, so there are some assemblies going on the surface. So this DST composed of several valves and several components, and this component needs to be actually inserted into this. And then, as you can see, this is still we are in the tightening phase of the main tool. Okay. This is the tongue, and this is the slipper, and then there are different drilling component that needs to be. As you can see, this is conducted during the drilling, and after we drill our new hole, which is our reservoir potentially. Okay. And then in order to check out the productivity and the properties of that hole, we need to actually run this DST. As Dr. Ahmed mentioned, there are several data that will be determined and defined from this kind of operation. Okay. And this is, a video also showing you the top view, and this is actually the rig, and this is a normal rig actually. This is tripping in. So we trip in order to collect. So as you can see, this is the data, the pressure versus time. And this is very important for us because it gives us the info about the availability of those data. And then the packer will be set in the place. As you can see, we need to seal off the reservoir. And then after that, the tool will be opened. As you can see, we can see the change of pressure, and then there will be some the first will be our initial flow after opening the tool. Initial flow, actually, as you can see, the flow will be inside our valve, and after that we will have an initial period of shut-in also. So we shut in the valve, and then the pressure will increase. And after that, there will be another open, flow, and this will be our final flow period. And this final flow period, all the, and then we will have a final sharing. But the majority of the information, permeability, others will be coming up with our final, and then after finishing the final sharing, we need to unset the packer and trip out of the two of the well. And as you can see, there will be also some reflection of the pressure. And then at the surface, there will be, dumping up, and, the samples will be collected from the surface. And then we need to dump the oil, of course, from the string that will be used. And then after that, we need to gather and pull off the electronics. As you can see, the gauge and other, memories are included there. And then this needs to be opened and sent to the surface facilities in order to actually upload the data within the gauge. Okay. As you can see, there will be grinding of the sample and then finding the gravity of the sample. Okay. So oil gravity. Reading out will be done in this stage. Okay, so here we are going to see the data, print the data, evaluate the data, and then give the info for respective department for decision making. That's it. Okay,
Okay, but that one I done, I think, by presentation.
Yeah. Thank you, Dr. Ahmad.
No
Let's
problem.
open the Q&A session.
Yeah, please. Yeah. If
Yeah.
anything, I will be happy to answer those.
Okay.
Hello, doctor. Can I ask
Yeah.
a question?
Okay. In this case, I need. Okay, Iman, one moment, please. Others, please turn on your video. Now this is the time to turn on the video for all of you, because we will have also a group photo after finishing this presentation. So turn on your video, please, all of you. And then, Iman, you can go on for your question.
I can see the group of the people also.
Good.
Very
Hakim,
good.
I can see you with others. Great. Damia, good. Right. So, Iman, you can proceed with your question.
I want to ask, is there any innovation in well testing?
Yeah, normally there are many innovation in well testing, especially utilizing the machine learning, So yeah, because the testing itself is expensive, and sometimes if you miss the both of the measurement on time, you cannot measure after that. For example, when you put the well on the production or something. So sometimes you need to use those kind of the technology, like the machine learning, to predict some kind of the data as well. So so using those kind of the technology will help us to customize and optimize the plan for the data acquisition and the well testing as well. Yeah, many. Yeah.
Okay.
Thank you, doctor.
Great. So I think we have, we can have other questions also. Other questions?
I can ask if no question. I can ask them. Dr. Mansoor.
Of course,
to test my audience, because normally I need to test first before I start my presentation, because I need to know how level of the deliverable I need to put, and after that what is the expect. I don't want to make the student boring, you know. So most of the time, first I will start with few questions, and after that I start my presentation to get the motivation and engagement, you know, to encourage them to listen to my presentation. But it was okay. I mean, it was a very good session with you guys. If there is a question, please you may free to ask me. If I can answer, I will answer. If not, Dr. Mansoor, he will answer.
Dr. Ahmad.
Yeah. So let me ask you a question to make it more interactive also. So just guys, for example, I don't know, most of them is a reservoir engineering or petroleum engineering, you guys?
Yeah, this is the first year, Dr. Ahmed.
First year, okay.
Yeah. That's why the level might be is not expected as
So
you
they
may,
study about the production, porosity, permeability. They have an understanding about the basic of the reservoir engineering.
Yeah, this is more basics on formation evaluation, basics on drilling, so grasping a very actually general info about the topics that involved in petroleum engineering.
Okay. So just maybe I will not go for question. Just I would encourage people to come to Petronas for the visit in our lab, in our facility here in the Petronas Research Center, to see those facility from the in front. And also you may plan your final year project and the visit, how you call it, the visit that you have it twice.
Intern.
Yeah, inter. We have several inter now working with us. So if you may interested also through our I mean website, you can apply and you can come and you are most welcome to come and to understand, because this is the right place that you can touch in the real industry and what really Petronas is doing. Really, we are international company now, and we are working in many countries now, and really we have a very I would say Petronas, we proud of yourself as a petroleum engineering and reservoir, please. And we proud of the Petronas also because it's doing very well. And now we are focusing on new technology and other aspect like the CCUS, CO2 storage, and new area of the technology and net zero carbon emission and other aspect like the everywhere. Please, you may focus on your plan for the final year project or other thing. And if there is any kind of the help or something through Dr. Mansoor we can provide to you guys. Yeah.
Dr. Ahmed, very interesting actually about this technology that you've just mentioned about CCS. Is it possible to just expand, this topic? Maybe you just, start with the synonyms and how, this student can actually go and ride on this trend for this net zero.
Yeah, sure. Actually, I have also presented, we have a presentation about the fundamental of the CCU that I presented to Curtin University and last December in UTP University. So in certain time, I can present to you guys as well. But in the general, CCUS stand for carbon capture, utilization, storage. Is mean what we are producing now. For example, we were producing oil and gas. Some of the oil and gas have a CO2, and normally when we separate this CO2 is not desired to sell. No one will buy the CO2 from us. Yeah. So normally this make the pollution and the climate changes, right? So normally based on the commitment that Malaysian government and the Petronas is make, and we think the worldwide, we need to reduce the amount of the CO2 in the environment. And this is where we call it net carbon emission by 2050. It means already Petronas make a plan to reduce the CO2 emission by 2050 by zero. It means no single CO2 in the environment, you know. So normally those CO2, what we can do with this CO2? So normally this CO2 can utilize for converting to the other product, because that we have a U in the CCUS is mean utilization of the CO2, and the storage is mean we permanently store this CO2 subsurface, because we cannot keep it in container or in the surface, because this require huge volume. So normally one of the thing, when we deplete the reservoir, oil and gas reservoir, because there is a subsurface place, normally we inject those kind of the CO2 subsurface by, not easy, very, very challenging, but we store the CO2 subsurface for time of the 1,000 year, not 50 years, not 100 year, for the quite long of the year, because this will be stored forever sometime.
Geological
So we
time.
need, yeah, so we need to be sure this storage is kept for longer time, no damage in the environment, no leaking, no kind of the issue with the wellbore and other facility. So normally now the project is moved from field development to the storage development, you know. So normally the storage development team similar to the field development piece, but bigger, because we need to take action on the not only dynamic simulation modeling, we need to take action on the geomechanic, we need to take action on the chemical modeling, in thermal modeling, and other aspect of the modeling. Very, very complex, but just to announce you, by 2 years time we will have the first storage in Malaysia, in the Asia as well, as a M1 project. So we're gonna to produce from Kasawari field, that has a high CO2 content, and we move the CO2 and to the one of the site called M1, and we store the CO2 there. And by doing that one, we can develop the field that high CO2 content, you know. When the field, in Malaysia, we have a several field with a high CO2 content. And one of the challenge due to this commitment, we cannot release the CO2 in the surface, because if you release, you will be penalized with a government, you know. So in that situation, we need to store. So by doing the CCUS is mean we able to develop those kind of the big field in Malaysia, and we have a good LNG, we can good gas sale commitment, and in the end of the day, we can have a good money. And you guys as a student, you can have a good sponsorship, and in the future you can join the company, and you can have a good salary as well, and the bonus. So so all this is hand to hand together, and I believe this is in briefing the CCS, this is the new thing that everywhere in the world now focusing, including Petronas. Yeah.
Great, great. Thank you very much for this actually descriptive information, and especially I think the majority of them are happy because of this bonus and salary, you know.
Yeah.
So
And in the future, they can find the opportunity in Petronas, and because most of I can see the faces local, so I believe all the local people and also the expect and have a chance to join Petronas. And we are welcoming all of you, and we can support all the students, yeah, in Malaysian
okay, so
students.
Dr. Ahmed, what is the you know, the percentage of a petroleum engineer after graduation to work on this CCS area?
Now you know we have a big department now, but you know moving to the CCS is not can be done one day, because the real knowledge, you know, you need to have expertise people. So normally only those have a high experience people can move and shift to the CCUS. So the one of the buckle showstopper is the knowledge and the experience. So, but we have a big department now called CMD, Carbon Management Department, and now is empty of the people almost. But they are pulling people to fill up all the boxes. But because many project is ongoing, so now we are a lack of the people. So if most of you guys can shift it, or your project can be somehow directed to the CCUS, I think you will have a good opportunity later on in your CV. You can mention, I mean, you have a familiar with the CCUS. And the hydrogen, please. The hydrogen also similar. So if you want to focus in the new area, one will be the CO2 storage or CCUS, and one will be the hydrogen. because the hydrogen also needs storage, and hydrogen is a new area of the energy. You can produce from the natural resources like the solar and other spec and geothermal. You can produce the hydrogen, you can store hydrogen, and you can produce hydrogen to use for electricity, for the car, for the industry. So hydrogen and the CCUS is the two new area that I believe that the student need to be directed and guided for these two hot topics.
Okay, thank you very much, Dr. Ahmad.
No
I
problem.
think your presentation actually covers those areas that are interested to all of us. It's memorable, consists
sure.
of several images, pictures, and and then it's informative. The majority of the info data actually are informative and can be grasped by the student, and also I was interested in the storytelling about the drilling part, about the logging while drilling, and accompanied all this kind of storytelling in the presentation. Thank you very much again, Dr. Ahmed, for your presentation, and I hope you are going to in the future there will be other also times that you can spend and you can actually allocate for us in University Technology Malaysia.
Yeah, it is my pleasure. Thank you for having me here, and thank you for you student also listening to my presentation. Hope it was, acceptable and meet your expectation as well. And I think thank you very much. Yeah.
Thank you. So in this case, I would like to ask all students to turn on their camera for a group photo.
It looks like we have a shy student as well, or not ready student, I believe, not ready.
I don't think so. They are shy. No.
Okay. Okay.
Okay. So turn on your video. I'm going to because there are two. Okay. So let's move on with the first page. I will. Okay. One. This is for the first 1, 2, 3. This is the first one. Let me save it. And then let's go for the second one. Okay. Save as. Okay, let's go for the second page. Okay. 1, 2, 3. Okay. Okay, so this one also is the second page. Okay, thank you very much.
He put the bear. I think this is one of your
this is the
students.
bear. I think Hakim is handing, is having that bear. It's okay. I think. So what is the symbol of the Chinese New Year this year?
I think rabbit. I believe rabbit.
Oh, rabbit. Okay,
so
okay.
that one maybe it was rabbit. I believe. I don't know.
So happy New Year.
Yeah,
Chinese
happy New Year,
and,
our Chinese
thank
friend.
you for all of you. See you in the future. Thank you very much.
Yeah, thank you guys. Thank you. Have a good day. Bye bye. Bye bye. Bye bye.